hematological diseases. And so far we discussed about normal values. I hope everyone knows absolute and normal values in hematology. TWBC, RBC, all these normal values. Then we discussed about various types of anemias, right? So what is the meaning of anemia? Decreased RBC count, HB or RBC abnormalities or blood volume reduction leads to anemia. Whatever the causes, right? So whatever causes that leading to some problem with red blood cell particularly, that will be an anemia, right? And hemoglobin, vice versa. Yeah. So then I want to discuss few more things in anemia. If you see the syllabus, there are normal values anemia. Then there is a bone marrow aspiration. Okay. These are the major topics in Unit 1. And we have leukemia. Leukemia we will discuss, and neutrophil abnormalities. Okay. 70% of the syllabus is focused on anemias in the Unit 1. Okay. Followed by bone marrow aspiration and neutrophil abnormalities. Okay. Any more confusion so far? No, right? Yes. Now, I will discuss a small topic about pernicious anemia, and megaloblastic anemia. Megaloblastic anemia. So what is pernicious anemia? Any idea? Vitamin B12 deficiency. So you are saying pernicious anemia means vitamin B12 deficiency results in pernicious anemia. Correct? Then what is megaloblastic anemia? What is megaloblastic anemia? Yes. So we can understand that it is a big cell anemia. That means big red blood cell anemia, right? That is called as megaloblastic anemia. What will trigger? What is the cause of megaloblastic anemia? Any idea? Spleen. So someone saying spleen anymore? Cause of megaloblastic anemia. Yes, this is also vitamin B12. Then how to differentiate? How to differentiate a pernicious anemia from megaloblastic anemia? Is it clear? So they both looks very same, and if you see the material in online or any textbooks, they will say B12 deficiency leads to either pernicious or megaloblastic anemia. But there is a huge difference, and we will see what are the differences between these two. Okay. So first I will show here. So far we discussed these things. So coming to the pernicious anemia. Pay attention. I think that will. There is over information there. I will keep simple diagram here. Okay. See here. Anemic condition, anemic patient. Listen here very carefully. Is an anemia lead to? I'm trying to say that. Can an anemia connected to GI issues? Is GI issues leads to an anemia? Gastrointestinal tract issues, can GI issues leads to an anemia? That is my first question. Then my second question, can anemia causes neurological abnormalities? Can anemia causes bone marrow problems? This we already know. All blood cells came from bone marrow. Any issue with bone marrow can lead to anemia. We know. This we understood. How GI issues, how gastrointestinal issues leads to an anemia? So Miss Muskan saying, so liver. How liver is connected to anemia? Liver producing hemoglobin? No, that's not possible.
Absorption of vitamins and
okay, very good. So should be saying that. So GI tract might, okay, you are taking some diet, right? So this diet will be absorbed by the intestine. After absorption, they will synthesize requirements for making RBC or hemoglobin. So they will stop anemia. Yes. I will discuss later. That is a jaundice condition. Okay, fine. I will justify Muskan. She will see bilirubin. She said. Okay, liver is related to a jaundice condition. Hemolytic anemia can occur because of some liver issue. Liver will produce an enzyme. Problem with this enzyme. Okay, problem with liver, problem with enzyme, problem with destruction of RBCs. So there will be an anemia. Agreed? Okay. Yes. Then GI. Let us see gastrointestinal tract. Moreover, liver. Yes. So as our should be said that some diet will be absorbed by intestine. If there are any issues with absorption of the intestine leads to an anemia. Okay, let us see what are these absorptions in the intestine. Okay, I am discussing about intestine things. Okay, so listen, there is a person took B12, vitamin B12. Okay, vitamin B12 has been taken by the person. Okay, this is through diet, either fish, egg or beans, chicken. So there are some diet, that diet has some vitamin B12. This has been ingested by the patient. Now, in the stomach, there are specialized cells. These cells are called as parietal cells. Parietal cells. Okay, what these parietal cells will do? These parietal cells, okay, so there is a vitamin B12 in the stomach. This B12 must be absorbed into the circulation. So this is blood circulation. Vitamin B12 must be absorbed into the blood circulation via parietal cells. Okay. Now these parietal cells will secrete a hormone or a component called as intrinsic factor. It's a factor, okay? Intrinsic factor of Kazil. Intrinsic factor of Kazil. This intrinsic factor of Kazil will attach to the B12 and that will be absorbed into the circulation. Okay. So now, if there is no intrinsic factor of Kazil, can I absorb vitamin B12? I cannot, leading to deficiency of vitamin B12 in the blood. Right? If you do a blood test, here you won't find B12, you won't find B12. The reason is there is no intrinsic factor in the stomach, leading to an anemia called as pernicious anemia. That is why in pernicious anemia, there is a deficiency of vitamin B12. Why there is the deficiency? Deficiency is because deficiency of intrinsic factor of Kazil. Deficiency of this factor lead to vitamin B12 deficiency, lead to pernicious anemia. Is it clear so far?
Yes, sir.
Okay. Now, let us see some interesting aspects of vitamin B12. Okay, pathophysiology of vitamin B12. I will tell you here some interesting things are there. Listen, vitamin B12 is essential for DNA replication in the cells. Vitamin B12 is essential for DNA replication. When there is a proper DNA replication, say for example, if they are erythropoietic stem cells, pluripotent erythropoietic stem cells, okay, when there is vitamin B12, red blood cells will be in normal shape. I am discussing about DNA point of view, the mechanism of vitamin B12. Okay, vitamin B12 will enhance the hemoglobin production, so the cells will be produced normally. This is how RBC is connected with vitamin B12. Parallelly, vitamin B12 is also very important for myelin sheath production. Vitamin B12 plus intrinsic factor, they together work for production of myelin sheath. What is this myelin sheath? Yes, this is a neuron. Okay, so this is a neuron, and neuron, this is axon of the neuron. Okay, axon. You can feel axon like a wire, a copper wire. Okay, you just imagine there are two copper wires without plastic coating. If you touch them, what happens? They will short circuit. The electricity will short circuit, right? When there is no insulation, that means plastic coating. So myelin sheet will act like the plastic material. Myelin sheet will insulate the neuron. Okay. Now imagine myelin sheet is produced by vitamin B12. Vitamin B12 is the ground material for preparation of myelin sheet. When there is no vitamin B12, there won't be myelin sheet. When there is no myelin sheet, the neurons will cross-react. If they started cross-reacting, what happens? You will feel a tingling sensation, pins and needle sensation. You will feel something is pinching you in the tips of the fingers. You will have memory issues. There will be discoordination of your balance. You will feel, you will get seizures, something related to neurons. See, a simple anemia leading to some neurological disorders now. You just imagine if the neurons of the pacemaker or AV and SA node got affected because of B12 deficiency. You will have a heart attack, you will have coma, you will have dementia, you can't be active. All of these things are attributed to vitamin B12 together with intrinsic factor. Okay, so there will be some neurological problems in pernicious anemia. Now you understood, right, how neurological problems are associated with pernicious anemia. The reason is vitamin B12 is essential for myelin sheet preparation. When there is no myelin sheet, there will be some neurological issues. So the different, and another one, if you go for diagnosis, in the diagnosis, what you will identify is, there will be MCV, elevated MCV. What is the meaning of elevated MCV? Increased cell size. The cell size has been increased. An indicator of megaloblastic anemia. Okay? Even in pernicious anemia, the visual appearance looks like a megaloblastic anemia. Okay? How megaloblastic anemia triggered? Parallelly, vitamin B12 deficiency lead to impaired DNA production. Impaired DNA production lead to abnormal RBC production, the enlarged RBC, leading to a megaloblastic anemia or elevated MCV values. Then, how to distinguish a pernicious cell with a megaloblastic cell? In both the cases, there will be a very large red blood cells. Am I correct? Both in pernicious and megaloblastic, there are large red blood cells. Then how would you differentiate whether it's a pernicious or megaloblastic? You will go for further testing of intrinsic factor. Okay, malabsorption issues. Okay, so what we will do is, we will provide vitamin B12 supplementation to the patient. So what I thought, I got a patient with anemia. I did PBS, smear, blood smear. I identified large blood cells. I thought patient has megaloblastic anemia. Then ideally what we will do, I will give vitamin B12 tablets to the patient. Okay, pregnant woman or anyone. I will give vitamin B12 and folic acid to the patient. Okay, so they took vitamin B12. Even after 1 week after taking vitamin B12, still I am getting megaloblasts. What is the reason? That means patient don't have issue with vitamin B12. The issue with absorption. Even though I am giving vitamin B12 to the patient, he is unable to absorb it. There is an issue with absorption in pernicious. Got it? So yeah, now you understood, right? When we given B12 supplementation, still the problem persists. That is an indicator of pernicious anemia. So further evaluations, what we will do? We will ask whether patient has a loss of appetite, some GI issues, stomach pain, indigestion, malabsorption, bloating. Okay. Now we understood. We ruled out that patient has intrinsic factor deficiency leading to pernicious anemia. Why patient developed intrinsic factor deficiency in the first place? Now our investigation going towards why there is an issue with intrinsic factor. Why the patient parietal cells or why the patient stomach not producing this factor. Got my point? Maybe patient has some autoimmune disorders where patient antibodies targeting parietal cells and destroying parietal cells. One criteria. Second criteria, patient might have some gastric ulcers. Gastric ulcers, damaging gastric lining, damaged gastric lining issue with parietal IF and leading to anemia. So now our investigation going towards a different direction, starting with an anemic symptoms. Okay, to GI issues. You got it? If patient has IF deficiency, intrinsic factor deficiency, we will go for investigating the reason for IF deficiency. Is there any ulcers? Is there any intestinal bowel inflammatory condition? Inflammatory bowel condition means there is an inflammation in the stomach. Okay. Yeah, that is a very big topic, but you understood, right? Or is there any autoimmune cells, autoimmune antibodies destroying parietal cells leading to IF deficiency? So this we will check. Okay. So autoimmune, autoimmune antibodies, or we can say auto antibodies against parietal cells. Auto antibodies against parietal cells of stomach. Some antibodies attacking parietal cells of the stomach. Our own antibodies targeting our cells. Okay, leading to this problem. Okay, so that's it. What lab test we will perform to identify IF deficiency? Usually we will proceed with ELISA technique. Okay, ELISA radioimmunoassay technique will assess the IF hormonal deficiency. IF is a factor, it's not a hormone. Okay, I'm making mistake there. Is everything clear so far? Pernicious? Okay. Any doubts? No doubts, right? The only thing you need to remember is how pernicious is different from megalo means even after giving B12, still there is a megaloblastic cells. Still there are large cells indicating an absorption issue. Simple. Got it? Just 2 days is sufficient. Give B12 for 2 days. Follow up. Tell the patient to visit again. If still the anemic symptoms are there, then it might be a pernicious. Okay. If we are not treating pernicious on time, what happens? There will be neurological issues. Neurological issues can lead to death. Simply. Okay. This is all about the pernicious anemia, and I will show some of the pictures here. Yeah. So usually I won't prefer PPTs, but you understood that there are parietal cells. There are issues with IF leading to pernicious anemia. Simple. Okay, intrinsic factor not there. And also, if there is intrinsic factor, maybe some anti-parietal antibodies destroying the cells, parietal cells. Some antibodies destroying the parietal cells leading to an anemia. Okay? The production of these antibodies will be many reasons. Okay? Due to some autoimmune conditions, these antibodies are produced. Okay, that will be another investigation. Why these antibodies are producing in the body? Is there any infection? Is there any other issues? That is a different story that we will see later. That's not part of Hammett. Okay, that is GI issues. Yeah, this is all about the pernicious. And as I stated, the common signs and symptoms will be symptoms related to neurological issues. Numbness, tingling sensation, loss of memory, vomiting, glossitis. Glossitis means hypoglossal. Inside the pharyngeal region, there will be inflammation. There will be a symptoms of tonsils. Okay, glossitis means loss of appetite. Obviously, they won't feel hungry since many things are going on. That whole causing noise, right?
Yes.
I will. Not now. It's okay. Next, 5. Yeah. One interesting sign of pernicious anemia will be thumb. Okay. There will be pallor. Pallor means paling. P-A-L-O-R. Not pallor. Okay. P-A-L-O-R. Pallor means paling of mucous membranes. Paling of mucous membranes. Pale means diminishing of color. Discoloration of mucous membranes can be seen in the eyes and in the mucosal, like in the tongue. Okay, this is an indication of pernicious anemia. Pallor, P-A-L-L-O-R, pallor. Pallor, okay, mucosal pallor. That's it. This is all about the pernicious anemia. Then, so as I stated, reasons of pernicious may be some, gastritis issues, intrinsic factor issue, or some synthesis issues. Cobalamin is the subproduct that we will see later. Okay. Yeah. Next one. How we are comparing. Okay. Next story will be megaloblastic anemia. What is the difference between pernicious and megaloblastic? Even in megaloblastic, there will be a elevated MCV values. Elevated MCV can be seen in megaloblastic. Okay. If you give vitamin B12 supplementation, there will be a recovery. There will be a recovery upon giving B12 supplementation. That is an indication of megaloblastic. Then, listen, is there any scales to measure the red blood cell size? How we are measuring? We will measure the red blood cell size along comparing it with nearby white blood cells. Okay, white blood cells is already big and so red blood cells are small. If red blood cells are similar to the size of white blood cell, this is neutrophil, and red blood cell looking almost same size as neutrophil, that is an indication of megaloblastic. Okay, usually RBC should be like this in comparison with WBC. Okay, when it is large, that indicates it might be a megaloblastic condition. Then second important condition. Second important. Okay. Now in this patient, parietal cells are functional, they are fine. Intrinsic factor is fine, but he developed anemia, megaloblastic anemia. That means the problem is with the diet. Maybe in his diet there is no sufficient vitamin B12 supplementation, resulting in megaloblastic anemia. Okay, because he has normal cells and normal IF. Keep in mind, his absorption is fine. He has an issue with the diet. Is it clear? Am I? Is it boring? Everyone understand? Yes. Then why no responses? Okay, megaloblastic clear, right? Now listen. Because of diet issues, the overall body will get affected in megaloblastic. What happens is the bone marrow cannot, bone marrow actually this is a compact, membranous, compact, then synovial. Okay, see, where does the red blood cell will be produced in the bone marrow? Compact bone marrow or spongy bone marrow? Spongy bone marrow. Or in the membranous? Yes, actually here there is cartilage and this will be around this region, okay, membranous. Okay, listen, my point is, when there is an issue with B12, overall cells will get affected, not only red blood cell, but also affected by white blood cells. Now what happens in the white blood cells means, there will be a multi-segmented neutrophil or hyper-segmented neutrophils will be seen in megaloblastic anemia. Parallelly with enlarged RBC, we can also find a hyper-segmented neutrophils. This is an indication of megaloblastic anemia in the patient. A simple blood smear is sufficient to identify megaloblastic. Okay, this phenomenon is not found in pernicious anemia. Got it? Yes. So this is all about megaloblastic versus pernicious anemia. Okay, so this is the PBS smear examination. So there is a hypersegmented neutrophil. Okay, So hypersegmented neutrophil indicates a megaloblastic anemia. Then you see here, you can see hypersegmented macrovalocytes and teardrop cells can be seen. Gradually the cell shapes are disorienting because of overall bone marrow issues. Okay, yeah. So this is all about you can see ovalocytes. So keep in mind, write down point in megaloblastic anemia in a diagnosis in PBS, in peripheral blood smear. You will identify hypersegmented neutrophils, then ovalocytes, enlarged red blood cells, and tear-shaped red blood cells can be identified in megaloblastic anemia. Okay. Teardrop, enlarged red blood cell, then hypersegmented neutrophils will be seen in megaloblastic anemia. Okay. Yes. Then that's it. So what are the natural sources of vitamin B12? So the natural sources both the meat diet have more B12 rich, okay, B12 rich in meat diet, whereas in some beans and peas there is B12. Okay, so this is all about the sources and treatment of vitamin B12. Here IF injections will be given. Okay, we will try to resolve issue with a GI problem. If you diagnose intestine, this anemia can be perished. What is other name? It will be disappeared, and here you need to give just diet. That's it. Okay. Yeah. Next anemia is G6PD. Do you remember what is G6PD? We already studied in the previous semester. Anyway, I will just explain in a nutshell. Okay. So we know that. Listen. Glucose 6-phosphate is a pathway in the glycolysis. Glucose 6-phosphate will be converted to glucose 6-phosphoglucarate in the presence of an enzyme called G6PD, dehydrogenase enzyme. This enzyme leads to a reaction where it will release NADP and NADPH along with H plus ions. Okay, that I didn't cut here. Okay, NADPH. This NADPH is very important to maintain the cell membrane integrity. Keep in mind, our red blood cells are under constant stress of oxidative stress. Okay, so there are free radicals, free O2 molecules, and these free O2 molecules will destroy the red blood cell. To maintain the rigidity of the cell membrane, red blood cell membrane, we need an amino acid called as glutathione. Glutathione is very important for maintaining the rigidity of the red blood cell membrane. The RBC membrane rigidity is maintained by glutathione. How glutathione is synthesized? Glutathione is synthesized by NADPH. Okay, there is some reduction reactions leading to glutathione, leading to protection of RBC from oxidative stress. Now let us see. When there is no this enzyme, there won't be NADPH, there won't be glutathione. So cell will be fragile and it will be easily lysed. Okay, so that is how G6PD deficiency leads to an anemia. Such anemia is called as hemolytic anemia. G6PD deficiency leads to hemolytic anemia. The mechanism is this. This is one important final question to you. The question will be like this. Discuss about the mechanism of G6PD leading to hemolytic anemia. So you need to give me this table. Okay? Keep in mind, I don't want biochemistry, detailed pathways, I don't want it. Okay? Basic understanding is sufficient in hematology. I don't want all those, in-depth analysis, how reduced, how hydrogen ions. No, I don't want the pathways here. I just need overviews in hemat, okay? Is everything clear? Yes. So G6PD is clear, Pernicious is clear, then megaloblastic anemia is clear. So that's it. These are the ROS, okay? ROS means reactive oxygen species. Reactive oxygen species will be developed in the absence of G6PD. Okay. G6PD absence leads to ROS formation. ROS will destroy the cells. Okay. In the presence of G6PD enzyme, G6PD is a strong antioxidant. You can remember, G6PD is a strong antioxidant. It will act as an antioxidant. Okay. When there is issue with G6PD, it leads to this. Now, I will some normal physiological process. Listen, when you are eating a diet that has more ROS, there is a more RBC destruction. Keep in mind, I am telling again. There are some. Okay, I will give simple example. You already know. How many of you got yellowish urine after eating spicy food like biryani or spicy content? You know that kala mirchi, Dalchin, those things, small balls. What is that? Biryani. Black pepper. Yeah. Black pepper. Listen, actually these spices, these grains has a oxygen species, process. Process will be produced by spices, and more process, more lysis, and more bilirubin production, and produced bilirubin will be excreted in urine, and that's how spice food leads to an yellowish urine. So everything is interconnected. Cautious with your cells, okay? They are very, very fragile. If you are destroying RBC, game over. Okay. So this is all about the G6PD. Next story. I'm going further. How many minutes we have? How many minutes left? 10 minutes. 10 minutes. Okay. I will finish soon. Okay. Keep in mind. I will try to finish. Yeah, G6PD, same story. Okay, NADPH reduction in these things. That's it. Okay. So yes, next one, reticulocytes. What are reticulocytes? Tell me, students. Yes, what are reticulocytes? Mature or immature? Immature RBCs are called as reticulocytes. Am I correct? Immature RBC is called as reticulocytes. Keep in mind, to understand anemia, reticulocyte count plays a paramount of significance. That means very important significance. Okay? How reticulocytes will evaluate an anemia? Why reticulocytes are damn important in understanding anemia? Okay? So my third story is reticulocytes. Why reticulocytes are important? Okay? Let us see what is this reticulocytes and their significance. Can I write them? You can able to see this area, right? Yes, I can use this area. Listen. Keep in mind, students. Bone marrow. Bone marrow is responsible for blood cell production. Am I correct? Now let us see one thing. Okay? Let us see two conditions. I don't know how to tell this condition. Let me see somewhere. Yes. See here. I want to know whether bone marrow working properly or not. Whether bone marrow working properly or not working properly. Why the patient getting anemia? Okay. Why the patient getting anemia? Now see very carefully. Imagine patient got some anemic condition. He got an anemia. Patient got anemia. What is the meaning of anemia? RBCs are destroyed. RBCs are destroyed. So patient got some anemia. RBC destruction led to anemia. Now what bone marrow will do is, keep in mind, bone marrow, what it will do? Bone marrow will increase RBC production. Am I correct? There is an anemia. Bone marrow will increase RBC production. Okay? Usually there will be 1000 cells per second. But now, since there is a destruction of large amount of cells, bone marrow started producing some 10,000 cells per second. Instead of 1000 cells, now 10,000 cells are produced by the bone marrow. During this response, during bone marrow response to the anemia, it is producing more cells, lead to slightly increased reticulocyte reticulocytes in the circulation. Normally some 2% reticulocytes should be there in the circulation. If there are more reticulocytes, that indicates bone marrow working properly. Bone marrow working properly to compensate anemia. That means in anemia we must find increased reticulocytes. In anemia there should be an increased reticulocytes in the circulation. Increased reticulocytes indicates bone marrow working properly. Why we are getting more reticulocytes? When bone marrow producing more cells, there will be some leakage of immature cells into the circulation. Got my point? So I need more reticulocytes in an anemic condition. Keep in mind. Is it clear? In an anemic condition, bone marrow producing more cells. Outcome of more cells will be more leakage of some abnormal reticulocytes, immature cells. Okay? Now imagine there is an issue and reticulocyte count is less. This is very dangerous. That indicates bone marrow is unable to activate. Bone marrow dysfunction. If the bone marrow not working properly, how we can create cells in the body? It is bone marrow's responsibility, right? How we are checking bone marrow status? By reticulocyte count. In an anemic condition, there should be more reticulocytes. Even in anemia, when the reticulocyte count is less, that indicates a dangerous condition. A dangerous condition, focusing towards bone marrow issues. Why bone marrow unable to produce my cells? Is there any cancer? Is there any deadly drugs that destroying the bone marrow? Bone marrow is like a stem cell hub. Bone marrow keeping us alive. All cells are dependent on bone marrow. When there is an issue with bone marrow, game over. It might be a deadly anemia also, or leukemia. It might be a sign of cancer. Okay. So yes, reticulocytes simply will give the status of bone marrow. When reticulocytes are less in an anemia condition, that indicates it might be a leukemia. That means a cancer to bone marrow. Very dangerous. Okay. So see, simple reticulocyte count giving us a very deep insights of the body. Keep in mind, the world's most costliest drug, an injection of 0.5 ml will cost 100 crores, and that injection is targeting bone marrow therapy actually. In India recently we got a government sponsored 20 crores and they reduced. Okay, they are trying to make this injection in India actually. Forgot the name, something. Anyway, see, that means these are expensive diseases, and that expensive disease can be understood with a cheap test. That is reticulocyte count. 50 rupees test will give us insights of the diseases. Okay, yeah. We'll see how this works. Array is not detected. Yes. So what are the issues leading to decreased reticulocyte count and increased reticulocyte count? You already understood, right? Increased count indicates an anemia. Okay, there might be some hemolytic anemia, excessive blood loss, even yes, even in cancers there might be increased cell count. Whereas decreased indicates bone marrow issues, complete bone marrow or other problems. I have one table actually. I want to show that table to you. Yeah, this table all I want. Okay. Appropriate reticulocyte response indicates when there is a proper reticulocyte production, that indicates either hemolysis or bleeding. This can be manageable. Hemolysis, we will try to understand what is causing hemolysis. We will treat it. Bleeding, we already know. Okay, internal bleedings, we will treat it. Then, inappropriate reticulocyte response. Why reticulocytes are not producing by the bone marrow? That might be due to liver issues. Maybe liver is in the third stage or fourth stage. Okay, liver destroyed completely. Or there is a kidney issue. Kidney issue in a sense, erythropoietin. Even the bone marrow produces cells, they are dependent on erythropoietin. When there is an erythropoietin deficiency, that means kidney issue, resulting in anemia, a threatening condition. Endocrine disorders, most of the hormones hormones affected, when there are any issues with hormones, that leads to an inappropriate response and bone marrow disorders. Okay? So these conditions treating is very tough compared to them. Okay, that might be simple malaria or some internal bleeding, but this is very tough. Okay, so these things will be understood by reticulocyte count. The normal reticulocyte count, write down, normal reticulocyte count is 0.5 percentage to 2.5 percentage. Normal reticulocyte count is 0.5 to 2.5 percentage. Okay. Now, the fourth stage of this lecture I will discuss in the next lecture then. Okay. Let us see. There is an issue with the reticulocyte. Reticulocytes are very less in anemic condition. That indicates a bone marrow issue. Okay. So how to diagnose bone marrow? How to collect a bone marrow sample? That is called as bone marrow aspiration. That I will discuss in tomorrow's lecture. Okay. Thank you very much for today. Yes.